Okay, so briefly, in conclusion, for my little wood gas stove experiment there, remember that's the first time I've actually tried burning wood in it. And of course, the reason I want to do this is so that I can actually, heat up some food with it at a later stage. What I've learned is I've got to make sure the fuel is very small, firstly. I believe that part of the problems was the fact the fuel wasn't quite small enough. So, we did have some characteristics of the wood gas reaction in the early stages, in the early videos, but it wasn't quite perfect. It didn't get perfect until the very end. Now, that can be because of a couple of reasons. Number one, the wood was not uniformly or sufficiently burning at the top. And number two, the stove itself was not at the right operating temperature. Now, I know it's a small stove. Adding more stuff to it did help. But getting the fire going on top properly was the thing which really did it. And that helped to heat up the whole stove, get the air convecting up through between the two tins and out through the air holes. And then that provided, the perfect, not just something with some of the signature of a wood gas stove reaction, but a proper, full-blown, yes, we've definitely got smoke being reburned by the hot air which is coming out of the vents type reaction. Alright, so these things do require skill to make. It's not like your propane stove, in which case you just turn a knob and light a match. Okay, it's not that simple. It requires a bit of work. So it probably took me maybe 10 minutes. No, it was less than 10 minutes to get the thing going properly, roughly speaking. Then, towards the end, it was about 25 minutes after having done the initial lighting that essentially we were down to charcoal that was smoldering. Now, the charcoal itself didn't seem to produce enough of the gases or enough heat to sustain the flame reaction, although we still had smoke coming off it. So I quenched the flame with water, and I'm going to dry out the charcoal and possibly use that with a different burning experiment at a later stage. So maybe out of the 25 minutes, maybe I got like 15 minutes worth of usable burn time of a stove of that size and type. Now, people do make wood gas stoves of larger dimensions, and I've got to work out whether it's height or width that's required. My instinct would say that a good combination of both height and width is required to actually make it work and make it work well. So now it's a question of whether I go down to the hardware store and buy sheets of metal and use a pop rivet gun to, fix the sides together, and or whatever. It's going to take a bit more experimentation. I haven't actually seen an experimenter's blog which gave the results of dimensions, which I personally regard as a problem. I see that as a big problem if we're going to try and create wood gas stoves with specific burn times. Like, I would like to make a wood gas stove which has a burn time of, let's say, 8 hours. Why? So that I could then fit a metal duct above it with a fan on it, okay? So the flames would heat the whole duct, not go into the ducts, but heat the whole duct. And then the fan could then draw air through the ducts, and then that could act as like a wood-powered fan heater for a house, maybe, if the wood stove was outside in a windproof area and the duct was aimed into the house. That would be interesting. But you got to think about how much height. Now, if a stove that size will only give you 15-20 minutes worth of burn time, let's say, to make the mathematics easier, it's 15 minutes worth. I would need one more than 4 times the size to get an hour's worth of continuous burn. For 6 hours worth of burn, I would need 6 times 4, 1 to 6, 2, something 24 times the volume of that wood gas stove to have 6 hours worth of burn time. Is that feasible? I don't know. Probably not. Anyway, it's all fun speculation, and now I seriously got to get some sleep.